Okay. So this is a kind of system. There are 3 pulleys, there's a string attached, the same string goes right from your hand to the other end of the ceiling. This is a platform. This pulley is attached to the platform, so if the platform goes up, the pulley comes along. Okay, now you are holding the string and the whole system is in equilibrium. The mass of this man is suppose 25, or suppose he is 50 kg, 25 would be too less. He is a 50 kg man and the platform is suppose 25 kg. Now the question is, how much tension would there be in the string, or how much force this man has to apply in order to keep the platform stationary and hence himself being stationary? It's a good problem for practice. Try to work this one out. To approach this kind of problem, suppose they're asking what is the force for the system to be stationary, then what you should do is, you should draw the FBD first. From there things would be very clear, it will be easier to think. Now what I'll do is, I'll draw the FBD of this platform and whatever is attached to this platform, this pulley and the man. Let's draw the FBD of them together. This platform, the pulley attached to the platform, and the man standing on the platform. Let's consider these 3 as my system. So whatever the force is within these different parts of the system, that is internal force, and whatever the force is outside the system, that will be external force. And Newton's first law says that for the system to be stationary, there should be no net external force. What are the external forces? The forces would be perhaps at the contacts, at the joint, the contact between this rope and the pulley. That would be tension in the rope from both the sides. There is rope on both the sides, tension always acts away from the body, tension at these 2 ends of the pulley. Tension at the hand of the man, the rope that which will be pulling the man, plus the weight. So the weight of the man and the weight of the block, the weight of the platform would be 250 Newton and the weight of the man would be 500 Newton. So this is the proper FBD of the system. Now from the FBD you can see very easily that for the vertical equilibrium, 3T should be equal to 750. From here you can see that T should be equal to 250 Newton. This much of tension should be there in the rope, and this much of force the man should be applying on the rope, because the tension is equal to the applied force. We have seen that before. So the man should apply a force of 250 Newton at the rope for the system to be stationary. Now as you can see, once we draw the FBD, things are quite clear and easy to look through. If you keep on thinking and not doing anything on the paper, it may take indefinite time in order to solve this or any other problem. So when you get a problem like this, just start drawing the FBD. That's why we have learned to draw the FBD. It makes the analysis easier. Okay, now I'm going to show you another perspective here. You could have thought to take just this platform as your system and the pulley, not the man. That is also a legitimate way of going about solving the problem. So you can take just the platform and not the man. So in that case, your FBD will include the weight of the platform, 250 Newton, and there is another contact between the man and the platform. So you have to take that force also into account. So the weight of the man would be pressing the block, so the normal reaction would be downward. This is the normal reaction on the platform by the man. So this is the FBD of the platform pulley system if you're taking this as a system. Now you can go about solving this one as well, but for that you have to find this normal reaction also in order to find the tension. So previously this normal reaction was the internal force, because we took the whole man, platform and the pulley as a system. The normal reaction was applied on the platform, equal and opposite force was on the man. So that cancelled each other. That was an internal force if you take the man also into the system. So that was the benefit of taking the man into the system. It was, the procedure was easier than this. You can solve this as well, and this is no goddamn difficult procedure. This is also simple, and you should always try to on the initial stage you should always try and think of different methods of solving. Now finding normal reaction is easy, because if you draw the man's FBD, there is some tension upward, mg downward, and normal reaction upward. So in this case, tension plus normal reaction is equal to mg, 500 Newton. So normal reaction from here is 500 minus T. Easy. So now you can write the equation of equilibrium, that 2T plus N. N is 500 minus T. This will be equal to 250. So from here, 2T, not 2T plus N. N is downward. So 2T minus N is 250. So from here, you will get that 3T is equal to 750. The same equation that you directly got there. So the moral of the lesson is that the normal reaction, if you can avoid taking the normal reaction into the FBD, you should do that, because if you can make the normal reaction the internal force, then you should take the normal reaction as internal force and draw a simpler FBD like the one we drew before. So that makes, because it's a simple case. In the cases where things will be a little more complicated, then the previous approach will turn out to be a better one. Okay, similarly, I'm giving you another case, and this is again no paper, no pen problem. You have to solve it just by looking at it. Okay, so the man is holding rope on both the hands like this, and the system is stationary again. And this type, suppose I give you the man is a stronger one, is 60 kg, is having 60 kg mass, and this is 20 kg. So now I'm asking, what is the force that he should apply on both the ropes? Suppose he's applying force symmetrically, the force has to be the same on both the sides. Then what is the force that he's applying on both the ropes in order to keep the whole system stationary? So now your answer is yes, your answer is 20 Newton. 20 Newton is the right answer. Very good. Now I know what you did. You followed the first procedure of taking the man and the rope as the system to avoid the normal reaction between the man and the taking the platform and the man as a system to avoid the normal reaction between the man and the platform. And if you do that, the only external force is this T, 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 T. There are 4 T's of external force upward, and there is mg downward, which will be equal to 800 Newton. There are 4 T upward. So that gives T as 200 Newton, not 20 Newton. The T will come out as 200 Newton. I'm sorry. Okay, so nevertheless, T is equal to 200 Newton will be the answer that he has to apply on each rope.